Hello, and welcome to IGS, or Integrated Global Services presentation on Hot-tek solutions. The Hot-tek product line at IGS is specifically dedicated to addressing complex fired heater issues while performing these services on full operating conditions. So we ask for no change to charge rate, firing duty, or any operating conditions. The Hot-tek Solutions or Hot-tek Services department is used either to avoid an emergency shutdown or to take precious time out of a turnaround and perform those services under normal operating conditions, moving those out of the turnaround window. Hot-tek Services has been utilized for over 20 years at all major refiners and in over 20 countries globally. This is a very well suited and serviced solution package that we offer that we'll be covering that addresses many of the major heaters that we see in refining. Both the crude, the naphtha, CRU or platform heaters, flare, vacuum heaters, cokers, and steam methane reformers or SMRs. Many of the solutions that we'll be addressing during this presentation are going to be uniformly applicable to these heaters. So our hot access services, for example, where we are able to create viewports while the heater is operating under normal conditions, rather than having to shut down to create those viewports or access creations. This is applicable to most of the heaters that we see in front of us. The hot vacuuming service, for example, is more specifically designed for the SMRs, the SCR areas of the SMR, to clean the catalyst screens. But for the most part, the majority of the services that we're looking at are applicable to all these fired heaters we see in front of us. So the first Hot-tek service that we're going to be discussing will be hot access creation, where we're able to create a customized door or access port on a live heater. So again, these doors are completely customized. So we can do a very small core drill access if we're looking to address maybe a process tube that's fallen, slipped off its hanger, or we need access in a specific area for our hot inspection service for the LANCESCOPE to make entry into the fired heater. We can do something relatively small, like a 4-inch OD access drill. We could also do rectangular or square access ports, just depending on what we actually need to do once we're inside the heater. So typically we see sizes of up to 6 inches by 24 inches for the convection section cleanings, creating access for those areas. We could also see those sizes with the hot vacuum service to get us in front of the catalyst screens for cleaning. So again, it's extremely customizable. We're able to create access in both ceramic fiber lined fired heaters as well as hard cast line fired heaters, and we bring the access ports fully fabricated to be reinstalled. So pretty much once we make our access to the fired heater, we can then install those doors immediately afterwards, closing the access port. We're pretty much looking at the largest area that we would have access to the fired heater would be about the equivalent of having 2 viewports or 3 in the case of some of the larger doors when we're dealing with the convection section open at one time. Normally we're looking at under an hour between having made penetration into the actual radiant or convection section of the heater with our first entry to having all of the refractory removed and then reinstalled. So all of our practices when removing the refractory are specifically engineered to not disturb the surrounding refractory. We do a constant radio communication with the operator's room so that we understand if there's any sort of change in condition. And all these are done on negative pressure vessels. So again, we spec out those doors specifically for the areas that we're making access to ensure that one, we have the right material that's coming on the back of these viewport doors that we're creating access, and also so that we're not creating an eddy, so that the depth of the door when we're installing them is equal to the refractory that's already in place in that area. The access door creation service is also extremely important because it's a lot of the times the backbone or the jump off point for another service that we're installing. So again, we talked about it a little bit with the convection cleaning. The first step of a convection section cleaning on an area in a convection section that has absolutely no access to those process tubes would be to create access and to spec out and have everything agreed upon before we come on site. These door locations are always identified in our pre-project walk and agreed upon with the refinery or the petrochem facility, whatever the client may be, before we even come on site. So everybody's on the same agreement, and that's extremely important, especially to make sure if we're dealing with a bit of dated design specs or general arrangement drawings. So so we know that we're not, entering into something like where the process tube might be right on top of the refractory, or the convection section tube would be right on top of that. So these are all agreed upon before we come on site. And again, multiple services pin off of the access creation. So hot inspection services, if we're trying to get a specific angle, we can create access in an area that we don't have it. We don't have to be completely reliant upon viewports, especially in areas like if we can see this top middle photo, you can see that the process tubes are directly in front of that door. That's fairly common on single fired heaters, especially can heaters, where the viewport, the tubes are right in front of the viewports that we're looking at. So if we're trying to get past that area with an inspection lance, we're actually kind of caged in with the process tube. So we can come in either from the ceiling or the bottom to get a better look on perhaps a tube bulge or an area of concern in that heater where we don't have access currently. So moving on, it's a pretty smooth transition right into our hot inspection services, which is our ability to actually take video recordings from inside the fired heater rather than looking at it from the outside. So to get access for the LANCESCOPE, we usually require a roughly 3-inch opening for the lance to be able to maneuver once inside. We also have a high temp light source. Many of the fired heaters are hot enough where light isn't a concern for us, especially in the radiant section. However, we do have the light source, and towards the end of this presentation, we'll cover a hot vacuum service video, which is using both the LANCESCOPE as well as the light source, which has like a temperature limit of roughly 1,000 degrees F in order to capture the video. There's an autofocus on the light as well, with zoom capabilities that are sitting right around we'd have the ability to read 11-point font at 100 feet roughly. This is beneficial in some vessels or some heaters and not in others, where we have a lot of contaminants in the flue gas. So obviously, if we have a smaller lance, we have a 30 foot is our longest LANCESCOPE that we have. We also have a smaller 5-6 foot lance. So utilizing, let's say, the 6-foot lance, trying to look 40 feet up in a heavily polluted flue gas, you're going to be zooming. It's the same as if you zoom, a camera in the fog. You're just going to be zooming in closer on the fog. It's not going to be able to penetrate, which is why we will bring on the 30 footers in those cases. The Lance is extremely durable, water cooled, so it's able to handle temperatures of up to 2,500 degrees Fahrenheit. It takes video recordings, and we can pull stills out of that. So everything is video recorded on this, and we find that it's pretty beneficial to do this and then pull the stills from the video, because it takes a bit of maneuvering to get in place and get focused on what we might want to be taking a look at. So for example, if we're trying to analyze some refractory failure, we're able to do that. And if while we're positioning, we see, we pass by some process tubes or a hanger that might be of interest, we can go forward and put a hold to that and zoom in from the stills that we collected from that specific video. So here we will actually see, this is about 35 or 40 feet away, so it wasn't a very polluted area, so we were able to just stabilize the Lance at the bottom, and then zoom in up to the ceiling where we were addressing. Well, we found an external hotspot. We weren't really sure the extent of the failure, so we were able to put the Lance in at the 90-degree angle and zoom up to see the damaged area. And then again, on the right side, we can see the still image that we were able to pull from that video. And then this is another 2 stills taken during a refractory repair. So as you can see on the left, substantial amount of refractory damage breaching the outer shell as well, so we could see straight to outside from there. And we were utilizing the inspection scope the entire time during this specific application to ensure that we were properly restabilizing very fragile refractory that was surrounding the damaged area. And then on the right, we see the repair taking place. So the left side of the damaged area on the before has been completely repaired, and we are in the process of repairing the right side from this angle. Next service we're going to talk about is the hot tube descaling. So hot tube descaling, again, is done with a water-cooled Lance, roughly 30 feet. It is an angled tip, and we can utilize existing viewports, and we can also create access, of course, if we wanted to get a larger surface area. So if we're only worried about, let's say, we have viewports in the burner area, in the flame impingement area, and the heavy scale that we're seeing on the process tubes is only in this area, we can just utilize the existing viewports. If we want to address a larger surface area or a larger amount of process tubes, in that case we can create access, which will give us what we would need, whether it be on the back side of a heater or a row above it, to get a longer. If we are dealing with an extremely long horizontally run process tube, we might want access on the back end to get both sides. But what we're seeing usually with the hot tube descaling is we're trying to reduce either the scale is acting as an insulator, so we're losing too much capacity, or we are seeing that the scale is starting to tree bark, starting to delaminate or fall off of the process tube. And because of that, the process itself isn't cooling the scale anymore. So we're getting very, very high temperatures, sometimes 200, 250 degrees above what the actual tube is, because there's no process cooling that area. It's just like a flake that's heating both sides of the scale itself. All those loosely adhered scale particles can be removed with the hot tube descaling process. Again, we're using organic abrasive that's not hyper aggressive because we don't want to have the risk of actually using an abrasive material that has the potential to actually penetrate the process tube. So the material we select is not going to get a pure white metal clean like aluminum oxide or garnet we would see from blasting with this, but we also don't have the risk of popping the process tube. So this is the HTD in service, the hot tube descaling in service. We can see the flame impingement coming past the lance on the left, and we can also see the loose scale being removed with the blasting. The clean line there is we were removing all this heavy scale. So another thing that's important about the material selection or the media selection that we use for HTD is that it is an organic, and it combusts shortly after making contact with the process tube. So we're not actually adding any more material into the vessel. So the only thing that we're seeing is we might see some scale start to pulverize and move up through the stack. Heavier scale will land on the base, but again, no media from our impact will be left in the heater once we're leaving the process. So we have no downtime. We're able to remove, the insulating scale, which is kind of also going to be, giving us false high temperatures of the tube. And one thing that we are always very concerned about is, or I guess very aware of, is the difference between single-fired and double-fired heaters. So on double-fired heaters, we're going to be able to get more of a 360-degree access to that tube, which is a greater impact on the efficiency that you're going to see from the cleaning. It's also important that we understand the distance between the refractory, where that stops in relation to the process tube that we're looking at, and what the refractory material is made of. So we have abilities to do ceramic fiber lined heaters as long as our allowance between where the tube is and where the refractory wall is gives us the confidence that we're not going to do any damage to the refractory. In the case study that we're moving on to, it is a single-fired heater, and the refractory was very close. It was also castable refractory, so we were able to confidently move forward without any risk of damaging the material. So, as I'm sure everybody on this call understands the different metallurgy of the radiant tubes that we see in process heaters. I'm sure people have heard, non-chrome tubes don't really scale. This can scale much less. This is not true. The majority of the work that we do at both this facility as well as like when we address with ceramic issues that stop scale growth completely in the CTEC division is 9-chrome. So 9-chrome tubes are the most popular tubes to have the descaling, whether it be on the hot tube descaling, online or offline, with the CTEC ceramic coating application afterwards. But in this specific one, we can also blast 1 1/4, 2 1/4, 5-chrome tubes. Really, the metallurgy doesn't affect us. What we will see is that you'll see more of a tree bark growth on some of the lower chrome content tubes, where we are getting quite a bit of very, very high temp pieces of metal or oxidation that have come from the tube. But again, what I'm saying about like the scale or the oxidation or the scale not being able to be cooled by the process, once we remove that, we can see tube surface temperatures reduced by 100 to 200 degrees Fahrenheit, depending on how long it's operating and how heavy that scale is. We also try not to, again, since we're not introducing too much foreign media, the impact that we have on the heater itself is very minimal, but we also keep in constant radio communication with operations. So if it's very rare for us to have any more than 2 access ports or access doors that we've created open at once. Again, 2 would normally be if we're using the inspection lance at the exact same time that we're doing the hot tube descaling. Or we have a lighting issue, which is not very common in fired heaters, but we could always add the air-cooled light as well. And we did talk about the concerns that we have for the surrounding refractory and how we are able to select the areas that we're going to want to clean. Our case study before and after with the IR scan. We can see the significant temperature drop. So I'm colorblind, so the bottom section is a little difficult, but roughly 1,000. So we see again roughly 200-degree temperature drop on the process tubes, single fired heater, no damage, and again this was towards the bottom 8. So we have the ability to create access and do the entire heater if that's what's called for. We could also just do the areas that we have existing viewports in and address the tubes that are in those areas. So the end of the case study, again, surface temperature reduction, roughly 200 degrees, verified by the IR thermal scans that we just reviewed. This took us roughly 8 days. We did the bottom 8 rows of the tubes by utilizing existing viewports for cleaning, so we didn't even need access creation for those. And again, there was no damage, even though it was a single fired heater, so that there was more of a concern for refractory. No damage was seen by the refractory. What we're saying with single fired and double fired is when we're dealing with a normal double fired heater can have a 6-foot or 4-foot gap from the closest tube, tube burner fire refractory wall. So that is more than enough space to remove all concern we have for any potential refractory damage. The next topic we're going to focus on is the hot convection cleanings, HCC. So again, done online. We prefer, we've had some clients request doing this offline during the turnaround since most people aren't doing anything in the convection section. We prefer doing it online. It changes none of our timelines or cost. So there's no difference in doing it online or offline for operation-wise or time-wise. We do see a better benefit doing it online. So there's several benefits for doing the online cleaning. One is that we're able to see the benefit of the cleaning in live time. So the constant radio communication with operations, the operator room, the entire time we're on site. So that means like before we're going to remove a door, we radio down, hey, we're removing one door. Be it existing or not, is everything good? We get the okay, open that door. If we need to open another one, we call that in as well. Once we start working, we radio in, hey, we've begun the cleaning. Everything's looking good. Now, the hot convection cleaning is done via line of sight. So what we're looking at when we're doing the line of sight and having that constant communication while doing this live, it actually gives us a better cleaning result than doing it offline when we're not able to monitor the condition changes from removing the fouling. And the reason for this is because it's line of sight, the fouling doesn't spread uniformly throughout those fin tubes or studded tubes. There are eddies within that convection section, areas that are fouled much heavier or much lighter. So by doing it online, we're able to confirm, hey, we just saw a huge change. Let's continue to hit that area even though it might be clean. So this is a video of the actual cleaning and process of the first row of fin tubes. So as you can see, we've already done a decent amount, about a 18-inch area up to the left, and continuing down towards the bottom of the screen. Now, much like the hot tube descaling, we're using a media, being dry ice, that's not going to add any contaminants once we leave. So the dry ice is going to hit. Again, another benefit of doing this online versus offline is that temperature change is greater. So you get a greater impact of the thermal shock, the saponification of the dry ice hitting that hotter tube, and then helping remove existing fouling. Your majority of contaminants are going to continue moving up the stack. You're going to see a pretty immediate impact on the approved draft. The convection cleanings we see have the greatest benefit. A lot of them we do in crude heaters where we have a lot of process preheat. Obviously because, or any place that is steam neutral or steam short, it's a really, really great tool to help address those areas. There's usually not a huge need for the cleaning on shock tubes or non-fin tubes, but if we have several rows of or several bundles of fin tubes, we'll see a pretty solid impact with that. So again, we have the image on the left of the guys actually doing the cleaning through access ports. We can see that they're pretty evenly staged out. And we usually would like the spacing to be roughly 6 feet apart from each other, and then between each bundle of tubes. So the cleaning takes place very similar to like a windshield wiper pattern, which is why we ask for kind of closer access doors. So we're not trying to do one and then 20 feet later do another one, because what we'll see is the cleaning doesn't overlap enough while it's like passing. It's just too big of a gap, so we don't get as much clean as possible. So we do recommend spacing, whether that means we add a couple more access ports between the existing ones or all of them are added. Then we want to get with or consult the general arrangement drawings to ensure that where we're dealing with the spacing gives us access between these bundles. So in like this crude drawing on the right with our little blaster going between the bundles, creating that middle access is crucial, because that now gives us access to above and below those process tubes, which means that we're getting every just both the hot face and the cold face of those tubes while we're cleaning them, because we're getting the cold face from the upper blast. So that's why whenever we're quoting a convection section, we will recommend how many doors. It's your heater. You can tell us however many you want, but the reason that we're recommending the amount we are is to get the maximum amount of cleaned area. The access doors, when we're installing them in the convection section, and this is also true in the hot vacuuming service, we usually are creating doors that can now be removed. And we pretty much just created a viewport. It's just bolted on rather than hinged on. And when we're dealing with like an inspection access door or a refractory repair or a J-hook installation, both refractory repair and J-hooks we haven't gotten to, it's pretty common that we're going to want to weld seam the door back on, because we don't have the need to continue to get back and forth into that specific area. If we do, we could always add temporary doors, but again, the style of door, whether it be temporary, I shouldn't say temporary because the doors will last the same as the heater, but a removable door versus a permanent door. and the removables, hey, maybe in 10 years we want to get to this area again, or 5 years or 20 years, whatever it is, we want to get access to this area to do another cleaning, be it the vacuum service or the convection service. This access gives us that, or the removable doors give us the ability to just easily go in and remove it. So this is before and after. Again, no damage to either the fins or the ceramic fiber in the lining of the convection section. Moving into the case study, the firing duty, as you can see, decreases by 6 MMBTUs per hour, while our absorb duty remains the same. So we're getting a much more efficient convection section after the cleaning. Payback was under 6 months, and again, this case study included both access door creation and convection cleaning. So once the access doors are in place, every following convection cleaning, again, be it 5, 10, 20 years, depending on the state of the refractory that we have in the radiant section that is fouling those convection sections, that can we can use those existing doors, so that takes out a substantial amount of cost and time from when we're on site. Next service is the hot-vac service. So again, this is done typically, we can do side access, we can do roof access. Typically there's not access to these catalyst screens when we're on site. So we make the access. Once that access is there, we have those removable doors in place. We can come back if those screens foul at any time. In this video, we actually are going to see both the light, the inspection lance, and the actual hot vacuum cleaning the screens in one. So this was one of roughly 200 screens that were cleaned during this project. Again, we can see that there's a specially designed tip on that vacuum to ensure that there's no damage done to the screens themselves. And we're able to utilize the LANCESCOPE as a guide, as well as if we're not dealing with something that's 30 or 40 feet down in darkness like we are on this one. If we are able to utilize the line of sight, we can easily do that as well. So it's a very slow and steady process, but this entire project, both creating the access and doing the cleaning, roughly 200 screens, was about 5 shifts. So we're able to extend the life of the ID fan by doing this, restore the differential pressure drop, and our standard, what we normally see while doing hot vacuum service is we get 90% or plus of the screens, depending on how much access we're allowed to create. And by doing that, we clean the screens very, very close, if not back to design from the original installation. So our case study here that we're going with, we see a significant SCR pressure drop, due to fouling and upsets. We're extremely close by the time we were moving towards when we were moved on site as moving into a forced unplanned shutdown due to the ID fan constraints and possibly tripping due to the amount of stress that those fouled screens were causing. This is the before and after. Of course, we can see the very heavy fouling on the left and the clean screen on the right. Excuse me. So roughly 90%, a bit more than 90% for the roughly 200 screens that we were able to address. We saw the pressure drop, and we again see the final result of the SCR pressure almost identical to where we were at with startup and design. So completed within 5 shifts. We created the access doors. Payback was less than a year. And again, if we were ever needed at the site again, we have the removable doors in place, bolted down in the area. So we can come on site, just remove those and do it in even less time than we did the original project. Hot refractory repair. So this is probably one of our most common services. And what we're able to do with specifically engineered tools and procedures in place is when refractory fails internally and starts creating our hotspots externally, we're able to create access to that area. Again, the access that we create in the hot refractory, unlike in hot refractory repair, unlike all the other services that we've addressed so far, these aren't prefabricated doors. What they are prefabricated either baskets or plates, depending on the size of the refractory that we're able to install. They're anchored so that they're specifically anchored too. So we anchor the majority of the plates while on site. So that one, we can secure the existing refractory where the failure might have ended. So we might have a 2x2 hotspot, but the refractory failure is coning out internally. So the good refractory might not be a straight line with that 2x2. It could be quite further to the left or to the right, top or bottom, depending on how we're going. And then we can secure that solid refractory, that useful refractory in its place, secure, weld those baskets in place, anchor these back out, and then install new refractory. So we have an immediate payout on this. The benefits of this: we're not carburizing the steel anymore. We're stopping the spread of failed refractory. We're eliminating any threat of having to do an immediate shutdown, depending on how drastic the refractory repair or the damaged refractory is in that area, that's not common. We've seen massive failures where we're able to replace in sections. So we don't address, with the exception of very, very small refractory repairs, we usually don't address the entire failed area at one swoop. So we're trying to, again, minimize the impact that we have on that heater. So again, constant communication with operations as we're making our first access cut. These are small areas, so as we're repairing, the full failed area, we're doing it in very steady sections and making sure that where we're applying isn't having an impact from bringing in ambient air, because where this is only done on negative pressure units, bringing in ambient air more than what we would see in roughly a viewport or two being opened. So here we can see in the refractory case study, we can see some serious carburized steel up top. When we take an external IR of the heater, we're seeing temperatures above 1,000 degrees. We can repair these on both when we see very high skin temperatures, like over 1,000 if we have those limits there. We can also repair on the structural beams when we're seeing, the heat get past, in the radiant section especially, getting past the refractory protecting that structural beam and being on site, and then repair those areas. So another thing, we don't ask any change in operating conditions when we're doing the hot refractory repair. We're able to do it online in small sections and in relatively quick order. So we do, before any refractory repair is ever done, we will send a qualified person, be it a specialist or a project manager, on site to assess the area of damage, If we need to get an access point in another area because we really don't know the extent of the damage and we need to get the LANCESCOPE involved, we can always do that as well as like our first step before we actually do the refractory repair. But this will save us a ton of work, both before before having to shut down and turn around, but also to save the surrounding steel and refractory from progressing, as well as like we've seen significant areas of damage where the steam cost of just cooling those areas is substantial enough to justify the refractory repair. So before and after, we see substantial temperature trends. Those are now the coolest areas of the unit. And as far as the repair goes, we're pretty much trying to get you to the turnaround. It's pretty rare that we see our clients go in and repair our repairs, unless we've maybe used a different refractory so the heater's out of spec, but we're anchoring that area way more than any refractory installer would do that, and that's because we're overkilling that area to ensure that we don't have any spread or any like further failures for the spot that we're addressing. And the last service we're going to be covering today is going to be the hot specialty services. The hot specialty services are primarily in place to address when process tubes slip their hangers or start to migrate into an uncomfortable position for our client. We can easily do it if we see that an anchor breaks right on site, anchor it back down to the area that it's already in before it starts to migrate. In that, again, we're creating access. If we're trying to look at the area more thoroughly, we can create access, go in with the LANCESCOPE, and that access that we create will come with a prefabricated door, just like all of our LANCESCOPE inspections or cleaning services would come with those doors. And again, custom made to the size that we want for this area. However, when we're dealing with actual access that we create for restabilizing the tube, and by restabilizing, I don't want to give a false impression here. We're not moving the process tube. We are restabilizing it in the area that it currently sits. So we're making sure that it doesn't continue to migrate maybe into another process tube or into a position where we're really putting a lot of stress on maybe a bend or a sensitive area of the heater. So we're going to create access. We see the tube here that was of concern. Before and after, the J-hook is installed, or J-bolt is installed and welded back to the shell. Refractory is then backfilled in. The J-bolt's removed, or the excess J-bolt or J-hook is removed, and then a permanent weld is a permanent plate is weld seamed onto the shell. So again, we can put multiple J-hooks on, or J-bolts on the process tube, or any specific process tube, or a specific heater that might have multiple hangers fail. We can put multiple J-hooks in and install those. The metallurgy is always selected by the plant or refiner metallurgist. So we're not bringing in like our cookie cutter J-hooks and installing these onto the process tubes. They're specifically selected by the clients before we even come on site. We're just coming on site with them fabricated out per client specifications, and then welding done on site, and that's it. So we're, again, constant communication, no change to the heater, no change to the process, and there's no need to then crash the heater to restabilize the tubes. So that concludes the presentation. We covered our access creation, which is pretty much a part of all except for the refractory repair. which that's a different style access creation, our hot inspection services, and the benefit of being able to use that in up to 200 or 2,500 degrees. Our hot tube descaling, being able to remove loosely adhered scale on process tubes on both single and double fired heaters. The convection section cleaning, removing the fouling on those finned and studded tubes. The hot vac services, removing the fouling on our catalyst screens, and on the SCR, and hot refractory repair, which is again pretty much every applicable fired heater that has refractory that can fail, being able to fix that and at depth, and whether it be a ceramic fiber failure or a castable failure. So thank you very much. My name is Johnny Spatana. If you have any questions or concerns, please leave them for us and we'll answer as quickly as possible. And I appreciate your time. Thanks and have a great day.